So today I'm going to look at this thing here from Euler Precision. This is the eSAP-30. This is a active probe. This is, as you can see here, an engineering sample, because I sent these to a bunch of YouTubers and probably other people too, to review these things and have a look at them and get some feedback and show people what's becoming available soon. I showed this briefly in the mailbag already, but I'm going to look at it in more detail now because it's the proper review. It's actually going to be a promotional thing, so it's like they're doing a campaign to produce funding and that sort of stuff. So these aren't commercially available yet. This is like prototype units. They're aiming towards that goal, and so they want to be doing a campaign soon. And there'll be a link down below to that campaign to go and check that out and to buy yourself one of these if you want one. This is rated to 3 GHz. DC to 3 GHz rated. The target price they've indicated is going to be pretty good compared to other probes I've seen out there. So I think it's certainly worth a look. Now this has also been given to me at no cost by Euler Precision. I haven't been paid for this apart from receiving the product. But I will be giving my honest opinion about this thing. If there's aspects I don't like, I'll be saying it. Yeah, so I will be critical. I do feel like, it's the right thing to do to say if I don't like something. I will say that I don't like an aspect and why. But judge for yourself, use your own opinion. There will be other reviews. I know that Thomas Shearer has already published a review on one he's received. I'm sure there's going to be other YouTubers like I'm Side Guy has also received one of these things. So there'll be several of us to look at reviews from and form your own opinion from that. What do you have in the box? Start with the boring stuff first. USB cable and a charger. Apparently the final charger you get in these will be a black one, not a white one. I don't see it really matters anyway, but they want to keep it so it matches the set. They've already told me that. We have some probes on the end here. The selection I've got here are not quite the same as what you would get if you purchase one. So the set here is not quite what you receive when you purchase one. They've sent me some like prototypes and stuff they've got here as well. And I think the final one is more like this one here, I believe, is basically what's the final one's going to be. This one here. So we'll be looking at these and see how hard it is to actually use these things. Obviously, considerations that this is a 3 GHz probe, and 3 GHz is like a completely another level with test equipment, and so things have to be connected up very carefully, which is why there's these. We also have these cables here. There's a UFL connected to that end. I think it's an MMCX or something like that, and there's a pair of them there as well. So there's a male to male there and a male to a UFL. Doing connections to circuitry. Then we have a stand which is currently 3D printed. Part of their campaign is to actually get some moulds made so they can injection mould these things rather than 3D print them, because right now obviously it's prototyping. So one of the things I'm going to be giving feedback about once I've actually had to think about it is this stand, about how to design this in a way to make the mould cheaper to manufacture, because that's going to matter to them. I have a bit of experience in plastics, so I can give them some help with that. And then we've got the actual probe itself. So we've got this cable here, I don't know, what's that? Probably over a metre, maybe 1.2 metres, I'm guessing. What's good about this is it's got this BNC on there, which means you can use this on any scope. You can just plug this in. This has an internal battery. Now I've charged it a little bit already, just to, see if the charging circuit is okay and that sort of stuff. It's got a battery inside it. It's got an 18650 in here, which is why it's so big. This isn't a handheld probe. This is designed to be put on a stand, which is why it's got this stand that goes with it. But 18650 in there, which is replaceable. If you need to replace that cell due to age or whatever, you can just take it apart, put a new cell in. It's actually designed to be repairable. That's one of the things I mentioned in the email in the documentation, is that it's designed to be a repairable part. So if something gets damaged, it's fixable. I also believe they mentioned, if I remember rightly, that they will be making repaired information available for it at some point in order to aid repair process. There it is. So you've got a connector on the end here, which is an MMCX. That's right, I think I did say that right before. Got a cable going to the scope, which is the same sort of connector. So this, you plug a cable in here, like that. Or this one, which has got the UFL on it instead. And also the other end goes to a probe tip. Also came with this documentation, which is the actual report for this exact probe. So it's got the serial number on it. So it's basically a calibration report, I suppose, but this shows you what this particular probe is capable of doing. So I'll get a bit closer. So there's the response characteristics, your capacitance. Then you've got some more here. Tells you the effective resistance. So you can see that at the lower frequencies the impedance jumps up, as you can see from this, which is meant for high frequency things, and for me that's a bit tricky because I'm not used to using high frequency stuff. So I've got to try and figure out how we can test this. I mean, my scope here is rated at 500 megahertz. It does about 640 at 3 dB point, so that's the biggest range I've got here. I haven't got anything that goes higher than that, apart from my spectrum analyzer, which can do 3.2 gigahertz. That's probably more suited to doing this test. I do have signal generator stuff here. I've got a Roden-Schwarz communication tester we can do. I think it's 2.7 gig. I've got a Marconi 2022D, which can do 1 gig. So there's a few sources we can use to actually do the tests on this thing. So the thing about high frequency stuff, it's about the rising edge speed. So how quickly the pulse time will rise, for example. So I actually have a Leo board and a pulsar here, actually got a couple of them, and I actually could put that through this probe and see what we're getting with that, and compare rising edges. I know what it is, it goes straight into my scope. We can also demonstrate that. So put it through this probe as well, and we can see what the rise time is like. So we can do a comparison that way as well, just to see what the rise time difference is between this and going straight into the front of my scope. Now, like I said, my scope isn't really up to the task of this particular probe. This is another level, like I said. Active probes you have to be really careful of. You can see it just here, 25 volts max. Right? Active probes are active, right? There's active circuitry in here, which are on the input, which means they've got very little loading on the device you're trying to test, but you have a limitation of voltage. You have to be really careful never to go above that voltage. Like a good thing this could be used for is like testing an oscillator circuit. You connect it to an oscillator, and you won't really load the oscillator down, in theory, and then that means you can monitor the oscillator circuit without loading it. Like if you try to do that with a normal scope probe, you could potentially even kill the oscillator completely, if not drag it off frequency. So it's good use for an active probe. Now I actually don't have any active probes right now. I don't have one. This is my first one. Now I have played with active probes. Actually, maybe I haven't done a review on active probe. I know I've played around with one. Rob from Siglant, he lent me one of the Siglant ones to play around with. Not too long ago, actually. I have played with active probes, and I actually quite like active probes. They are very nice, but you have to be careful with them. So that's the only thing. You have to be really aware about what you're doing. You can't just snap the probe or anywhere and go, oh yeah, I'll just poke around and see what we get. You can't do that with these things. You have to know exactly what you expect to measure first if you want signal purity and stuff, and not to damage the probe. Anyway, this stand here, which I mentioned about, the idea is that this sits next to your circuitry. You have your cable, which will come out, whichever cable you're using, and then you would stick these connectors on all these things. Let's go for this one. And this one goes straight in. That one there is designed to go straight into the probe. It's got a plug on it. Push it in. There you go. So that'll go straight into the probe. And in this case, you actually solder this directly to the chip or whatever it is you're trying to monitor. This one's got like a pair of pads which are quite close together. There's other ones here which are different. So like I said, they sent me some prototype ones. I don't remember which one they said people will be getting. I think I can't say this one or this one here, one of these two. I can't remember. Look at the campaign, it will tell you. But the idea of these is that you got the longer probe, so you can actually go to like a pin on an IC, and then the other one you can do to a ground pad, which like it could be a bit copper 4 stuck to the top of the IC or something. It's like a ground source or something, or to another pin of the IC which is grounded. That's the intention of these things. Different setups for different things. Let's say that one goes straight in. So these are all plugs that go straight on, and the cable we go into this one here. This one's different, which means you could then make up your own probe with this. You could put some pins on there maybe, or something like that. So you put some pins on that and make your own cable up with this particular board, and make your own test setup with that one. But say they sent me a few different versions to have a look at. Now, for my opinion, already, before even turning anything on and actually using it yet, is that the actual connection systems for hooking into this probe, I think there needs to be more options. although they've got a few in here they've tried and things like that. Things like this I quite like, where you actually do have probes which you can attach to a circuit. These are okay, but these are going to be like limited lifetime, aren't they? You might use them once or twice, or I don't know, with the time you get out of them before these start to get damaged and really no good anymore. It depends how careful you are with them, I suppose. Those to me would be like a consumable item. You have to get like a bunch of those. So I think when I do make these probes and release them to people, at the very least they should include a dozen of these things at least, of those flexes, if they're going to use that method. I think they need to include more of them. And other options for probing. I mean, you've got these little coaxes like this, which are nice, and that little board. I think more options of those, like, because the assumption is obviously because it's a 3 GHz probe, is that that's the frequency I'll be using it at. Well, in most cases, you won't be using the full frequency range. You might be using a fraction of it. To me, I would be looking at lower frequency stuff if I was using this probe. I'd be less than 100 megahertz most likely in a lot of stuff. Not always, obviously. Having an option for less precise connections for doing lower frequency stuff, which doesn't matter so much, that would be something I'd be interested in. I mean, to me, it's nice to be thinking about this and trying to figure out options and trying different things out. It needs more. This is a weakness, I think, is trying to connect to the probe. Now, one thing I do have, they did tell me, they're planning on offering 2 versions of the probe. One with this connector on it, and one with like a pin header or something on it, which I think they've included here. There's this one here. They've included a little pin header here as well to go in. Something like that anyway. So they've got options for which one to go with. You can go with this style or the pin header type, which will give you more customizable options yourself, I think. I think they included those so I could maybe try it if I wanted to. Been waffling for ages, haven't even turned the thing on yet. They've already told me there's a firmware update on the way for this thing. I discovered a small bug with the LED function and the way that works. And apparently they've already redesigned it, the aspects of it, so that's going to be changing. But it's a multicolour LED here. I think it's a addressable LED they've got in there right now. But apparently there's a bug the way it's communicating with the microcontroller. It's only a minor thing, it's just for charge status when you're charging it up. But they've already got a solution for that, so when other people get them, that won't be an issue. But they're doing firmware updates, and so I'm guessing you can plug into the USB port on the end here and do the firmware update through that. They've already given instructions, I just don't have the actual firmware update yet. Not at the time of recording anyway. So the button on the front here, as you can see, you can also tip it over like this if you want. The button on the front, there is only one button, there's the one thing. You push that, hold it down, it turns on. That's now green. Don't know what it shows on my camera. I can see it really well, but my lighting is kind of washing it out a bit here. The camera doesn't like the colour, but I can see it fine. So that just tells you it's on. There you go. So green on, and then it's flashing. So I think the initial solid green was when it's booting up, and the flashing is when it's actually running. Obviously it's pulsing to save battery power. Now when you charge it up, it will pulse on and off. Then charging it with red. I've got a USB supply just over here. Let's plug this in. And that's pulsing green because it's powered up, you see. Slow pulse. I'll turn it off. And now it's pulsing red. That's what it does when it's charging. The recommendation is to not charge this whilst you're using it, because your charger will introduce noise. Unless you've got a particularly good charger which is really, really clean, but even then it might be causing noise inside here from the charging circuit built into it to charge the lithium cell. Plus there's also the issue of the fact that this may be linked electrically. I don't know if it is or not, we should check for that. See if there's an electrical link between the grounding of this and the grounding of the tip. There could be. If there is, and that becomes an electrical issue as well for the circuitry. I mean, that could also be causing ground loops and causing noise that way as well. Let's just do a quick test and see if we're having conductivity between there and there. Let's try it. Stick it onto the casing of that connector. Yeah, they're connected together. So the charger ground, the 0 volts, and the connector on the end has only got 7 ohm resistance between them. So yeah, they're connected together. So another reason to not be doing measurements whilst connected to a charger, because you could actually be grounding your device out, and you might want it floating. So apparently they've already done like 10 front end designs on this thing or something like that. Anyway, there are loads of designs trying to tune the front end and get it to be the performance that they're looking for. And so they've got to that point, and I think 3 GHz is pretty good, to be honest. Like I said, there's a few little things which they're working on and they plan to do in the future, I mean, even though this is 3D printed, it's actually come out very nice. It is a very nice finish, even though it's 3D printed. I don't really have an issue with that. One thing I don't think I mentioned it yet, this probe, the reason it's got a stand, is that it's supposed to be not touched, right? If you're holding the probe, you can induce noise radiated off you into the probe. It's that sensitive. So it's not meant to be handheld, which is why it's got a stand, and you remotely mount it all, so you're not holding it. That's something you need to consider as well, that you need to mount the probe up and then run the cabling off from the tip to your test setup. It's not a handheld probe. We will pull it apart later on, have a look inside it. Right, we need to hook this up to something and do some testing. This is the biggest trouble I've got now, is trying to figure out what to demonstrate this on. So I've got a test setup jigged up here. It's not wonderful, but it's what I'm going to do for this demonstration, just to have a look at it. The thing, anyone that does proper high frequency probing is probably going to be screaming at the screen right now going, what the hell are you doing? Because coax, that's fine, flying leads, not fine, not terminated, not fine. So accuracy from what we're going to see in the waveform isn't necessarily going to be right, because you're going to be getting ringing on the cables, reflections and that sort of stuff, which normally we dump it down. This is coming straight from my signal generator. This is from my Marconi. I'm using that one because it only goes 1 gigahertz, but my scope, the 3D point, is about 640 megahertz on it. I can go above that, but then it loses a lot of bandwidth anyway. So this is not a particularly great setup, but it will demonstrate it working at least. One thing to consider is that I have all these LED lights here, and they generate noise that could show up on the scope. In fact, I'm sure it is showing up on the scope because of this less than perfect setup. So right now I'm injecting a 500 kilohertz 0 dBm signal into the tip of the probe, as I showed you my junky setup, and you can see the readings there for the levels and what have you. Now, like I said, I'm getting a lot of noise here. You can see the spiky stuff there. I could try turning some LED lighting off and see if that goes away or minimises. It might. Yeah, there we go. See that one? Took that one light off and it took most of it away. So I might just leave that one light off. Alright, so that's that light off anyway, so it's looking much nicer now, less noise being induced. And I also tweak my camera settings as well, so manual focus instead of autofocus, focusing weirdly because of the screen. So that's looking fine. So that's auto triggering, and that's that 500 kilohertz. So I might just try going, say, 100 kilohertz. Still fine. 10 kilohertz. Still fine. Levels looking fairly even. So let's go 1 megahertz. Yeah, still good there. I mean, this is nothing for this probe. So 100 megahertz. Got a level drop there, but that is probably because of the cabling. See this? All these reflections changing? That's me moving the cable around. Right, so it's my dodgy probing which is causing these levels to be really bad. So depending on what I do with these cables, it changes that signal level significantly. So because it's a high frequency, it's getting these reflections and what have you. So that's not surprising. It's not the unit's fault, it's my probing which is causing this problem. So let's do 200 megahertz. 300. Again, this is all because of reflections. Let's go straight to 500 megahertz. So it's come up again now, because that's because of these reflections. If I touch the cable around and stuff like that, see, it's all changing. It's my probing which is making that do that. But it's all there. You know, it's not really glitchy much. I've got a little bit of noise still riding on it, not much. It's a tiny little bit. If I do a single trigger, that will look fine. Let's actually increase the level over here. I'm going to be getting lots of losses from this cable and stuff because of these probings I've got going on. Right, back to just the normal trigger. 600. I mean, some of this will be my scope dropping down as well now. 700. Don't forget it's a 500 megahertz scope. 800. Now it's really limiting my scope there. But it's still there. The probe is still performing. 900. Still there. Again, my scope is going to be the issue here. I think I'm probably getting aliasing there actually. Based on that. Let's go back to say 700. Yeah. I think I'm getting aliasing there. 700 is definitely right. I don't think I'm getting much more above that. 750. Again, it's dropping right off. I mean, that's the limitation of my test setup, not the limitation of the probe. So right now I've gone back to 10 megahertz again, and I've just plugged the charger in to see if I can see any artifacts from that, and it's actually looking okay. Yeah, it's actually looking alright. There's no real distortion or anything on there from that charger being plugged in. So I think in my case, I could potentially use the charger, and maybe on not on high frequencies, but certainly low frequencies. It looks like it's fine. It's not really distorting it. Let me see if I can find another way of setting this up so I can do some better testing. So I'm looking through my cables and adapters and things like that to see if I've got some kind of cable I can use to adapt into this. I've got SMB, which is like the same thing but bigger. It's not the right size. So yeah, unfortunately I can't actually adapt straight into it to hook into my gear nicely. I don't have any suitable cables for that. I'm going to keep looking, but I don't believe I've got anything. Yes, I'm thinking that because I've got to get now some kind of adapter system to get a probe into this thing better, maybe this should be included maybe with a adapter, say from this MMCX to an SMA or SMB connector or something like that. Probably SMA, because SMA is quite widely used as well, so a lot of people have SMA connectors. Maybe Euler Precision could include an adapter to go from MMCX to SMA. SMA is also a high frequency connector, but it's not going to be quite as good as these, I expect. There's probably going to be some compromises involved with doing that. As long as you're measuring lower frequencies, that shouldn't really matter that much. Of course, every time you add an adapter or some other kind of coupling system, you're going to introduce issues, potentially reflections and what have you. Right now, I can't do a precision hookup until I get some better cables, and that could take weeks. I mean, there's nothing wrong with these connectors, it's just that I don't have any. I'll just have to get some. Okay, I managed to jank something together. This is a test board I've got for doing various RF stuff. It's actually got a through connection on it. It uses UFL. So I'm using the UFL cable from there to go to this cable to SMA, which is then going to a 50 ohm terminator. A BNC adapter. I don't have a male to male straight through, so I have to use this. And then that's then going to my signal generator. It's a bit less janky, maybe. Right, let's try this again. That's the 10 megahertz, 1 megahertz, 50, 100. Still getting some reflections and stuff there, but it's probably not too bad. 200, 300, 400, 500. So again, my test setup isn't perfect for this, but it's certainly looking better than it did before with the other slightly janky setup. 600, 700, 800. I mean, it's definitely going through to 800 anyway. 900 and 1 gigahertz, which my scope can't see. 950. There you go, 950. It's kind of there, but not great. But that's because of my scope, like I said, because it is only supposed to be 100 megahertz, but it's 500, really, honest. Right, another test. I've got it set up to my SSA here, and I'm doing a tracking generator source straight through that board which I showed before, which has got the through on it, using the UFL connectors, straight into the source of the probe, straight into the probe and back out again. There's the board, there's the probe. It's all sort of jankily set up here, and that's what we're getting out. Alright, so it's doing 1 kilohertz to 3 gigahertz. Now I've got a 10 dB attenuator in here and a DC block as well. They're both in the front panel. Just there's an attenuator and a DC block. I do those to protect the unit from any errors. Don't make a mistake and accidentally blow it up. So although it's a 2.1 gigahertz, it's not that anymore. It's an SVA 1032X or something like that now. I've modified it. You can see the bandwidth here, so it's sitting there. It's like 35 dB or minus 35 dB right there, and at 3 gigahertz getting like minus 40 odd dB there. 40, lowest probably minus 44, probably lowest point. And don't forget, this isn't a perfect setup. This is a bad setup. In fact, there will be ringing, there will be issues with impedance mismatches and stuff like that. So, you know, that's not unsurprising, but it is at least doing that full range, which I'm showing there. I could actually maybe extend the top frequency slightly more. I'll just go to the maximum it can do. 3.2 is the highest it can go to, and it's doing that too. So yeah, it's doing alright. I see better cables. So I should point out this cable on the side here. This is actually removable. That just clips in there, and it's actually a plug. It's very secure. Then we've got a connector on the side here, which we can pop out like that. So let's take this thing apart and have a look inside it. Here's the Torx bit. That's what it said it was. Maybe it's Torx 6. Hold on, what was it? Yes, 6. Torx 6, not 7. Right. Got the screws out here. There we go. Top cover, I'll leave the screws in it. So it's 3D printed currently, but it will be injection molded. It's not a design. If they try and injection mold this exact profile, that's going to be costly to make the mold. So there's the board. There's the battery, which is replaceable. It's in a holder. If I get it out, it's a nice fit. Shove that in there. Try and leave it out. There you go. It's a nice secure battery holder. It's got markings on it for which way around the battery goes. Let's take the board out because there's not much to see on this side. There's the other side of that. So we've got a let's get a bit closer. It's got a flexing section there for the button, which is fine. That's a perfectly good way of doing it. You've got metal threaded inserts in here, very nice. And we've got a diffuser light pipe set up there for the LED. Here it is. There's all the front end stuff, which apparently they've done about 10 variants of this, trying to gradually tune it over time to make it better, trying to optimize it. So there's the front end design, which you can see got the so the copper's all pulled back there to reduce capacitance on the input stage. No silk screen, no copper. Improve the matching and what have you. Very nice. There is flux residue still around here. I would have thought that would have actually been cleaned off. Flux can affect things, so I would have thought that would be gone. It's probably a wise thing to clean that flux off. It may not matter, but I know from my experience that flux can do things like affect oscillators and stuff like that. It can actually affect things. You always try and get it off in RF circuitry where possible. But it's nice. Nice design. It's got a conformal coating on there as well. Not on the whole thing. Just on the back end here. Got some fingerprints in there. You can see that. Got some test points there. Obviously that's the output of it, right? So there's the output there, input there. It's all this one chip in and out. Then I've got these supporting circuitry around here. Power supply stuff. Now these are some of these bodges that I mentioned on the information they sent me, where they've redesigned some of the circuitry, and this will be solved properly later on. This is a temporary situation for the engineering samples. Obviously they're still doing development. I like the fact they've got voltage test points set up. Very nice. And the back end here, U501's probably a lithium charge device. Guessing that's a charge controller for the lithium cell. So we've got some polarity protection, fuse. Let's get some fine tweezers. Yeah, it does lift off. Those are connectors. Lovely. There you go. And that's what's underneath that can. So that can is shielding that switching supply there, to try and stop noise getting out. That's a nice little design feature. So yeah, just a switcher under there. So it's all part of the power supply stuff. So this is basically all power supply stuff down this end, probably down to this point. There's a little microcontroller there which is controlling other stuff. And then the actual amplifier down this end, well separated. Nice. Put this can back on again. So there's that chip there on the input. Is that BUF 802 from TI? And some other chip here. 0140, is it? There's a 0140. I think that's what it says. A3901, 215, and don't think I can see that chip because of the form coating. Yeah, form coating's hiding those. Not intentionally hidden, it's just a side effect of the coating being there. You can scrape your coating off and find out what they are. There's something that was commented in the documentation that they sent me, was that this connector here is going to be moved further to the edge, because when it's got the casing on it, it makes it a bit tight for this connector on the side of the casing. They're conscious that it's not quite a perfect fitment, so they're actually going to move this connector. So obviously when I do those corrections for these little bodges they've got in here to these corrections here, when they redo the board to allow for those modifications, they're going to move that further out as well to create more room for that connector. But yeah, it's nice. Thanks a lot Euler Precison for sending this to me at no cost. That is brilliant. I really enjoyed looking at this thing. And it's a new tool which I don't have in my arsenal right now. And it's great to have an active probe in my arsenal now. So I didn't have an active probe before. Now I own one. I've already ordered some adapters and extra cables, stuff like that, so I can adapt into this MMCX connector system. So I've got some more cables coming. I've ordered them. Connecting to it shouldn't be an issue once those extra parts arrive for me. So I've got some extra coax cables and some adapters, so I can adapt from MMCX to BNC and SMA. Some cables themselves as well to give them some extra length so I can extend them. I've got some sacrificial cables which will be MMCX male to male. I'm going to cut them off and strip off the coax on the end, so I've got connections straight on into the coax. Things like that. I'll be able to do that with it and just make some nicer attachments to things. But like I said, I do think that they need to supply some options. I mean, they've got the flexes here. They need to supply more of them because they are going to be consumable items effectively. And also maybe some adapters or some alternatives for lower frequency connections. Because everyone's going to be using it at 3 GHz. Although it's capable of doing that, chances are you've been using it at lower stuff most of the time. So yeah, that's brilliant. Thanks so much. Don't forget to check out the links down below to Euler Precison. Maybe buy one. They're very cheap compared to other probes that are out in the market. Other videos to watch down below. There's a subscribe link over here to subscribe if you're not already subscribed to my channel. If you found it interesting as well. There's a Patreon link just over there. You can donate to the channel and give me a tip. And that will allow me to buy more test equipment to do repairs on and look at and do mailbag things and like that. Helps the channel. All the money I get from the channel goes back into the channel. It's not for my personal gain. It all goes back onto the channel. All of it. And some. It actually costs me money to run the channel. There's also a new feature down the bottom there somewhere. So you've got thanks. So there's also a new button down there which is coming soon. You'll probably be there by the time you see this video. Called the hype button. That helps to promote my channel. So if you click the hype button, that helps push my channel out. Hopefully more people will see it, which also helps my channel a lot. So if you want to do that, it'd be great. Catch you later.